All right. Today we're going to go over another book. This is going to help you in figuring out some electronics projects. So this video is going to be for those who have been asking, how do I learn electronics? How do I teach myself electronics? One of the best ways to teach yourself is to start to learn and understand schematics by reading schematics. That's how I learned electronics. I've made previous videos, people asking me how I learned, and I told you I was going to make a video that will cover how I learned. Now, this is not the book that I used to learn. I didn't use a book. I used basically schematics. Schematics having to do with the kind of electronics that I was interested in learning, and I really just picked apart schematics, stared at schematics for hours and hours until I understood them, for weeks and weeks and years and stuff like that. Okay, so that was my primary way of learning electronics, was really reading schematics. Okay, so this is something that you can start now. Just because you don't understand it yet doesn't mean you shouldn't do it. So I'm going to we're going to go through this book, and I'm going to give you kind of the method and what you're going to do and what you're going to look for in reviewing these circuits. So this book, these books are very common. You can pick up any of these kind of books. I'm going to leave a link to this book in the description of this video so you guys can have it. It's just in a PDF form. It's something I just came across. I'm a member of a lot of different like Facebook groups and book clubs, if you want to call them that share lots of PDFs of science books and educational books and what have you. And this came across in one of those forums, and I downloaded it because I thought it'd be perfect for you all, for those that are trying to learn electronics. So I've never owned this book. I've just flipped through it a little bit. Again, these kind of books they're a staple in the electronics community, because they are for people that are just beginning, or just people who want a reference to some common circuitry. Okay, and that's what we have to do. Not everything that you do in electronics is unique or has to be unique. You don't have to figure out every circuit from the bottom up and design it. You can look at other circuits that are pre-existing and go from there. And maybe you can tailor it to what your specific need is, or to the specific components that you have available to you, or you can redesign it there. So basically what we're talking about in a lot of ways is we're talking about education and learning through reverse engineering. Okay, everything in this book has been engineered. We're going to reverse engineer it, and that's how we're going to learn. So that's how I learned. I learned by reverse engineering. Okay, so before I do that, I just made a quick list of some items of how to, or the steps that you're going to take to self-educate yourself in electronics. Okay. And I'm going to actually add one more thing here, which is going to be learn schematic symbols. Okay, so the first thing that you want to do, and this is kind of in conjunction with number 1 and number 2. This is why I wanted to put there, because it was kind of implied through number 2, which was number 1 a second ago. It's learn schematic symbols. So you need to learn on your symbology. If I just do a quick, I can do a quick search here. Oh, I see. One of these tables, there's in the practical electronics book, there's a good table in there. You get one of these tables. This might be good, especially if you're just starting out, because it has some good descriptions there. We'll look at that real quick. Something like this has more technical stuff. It has a lot of MOSFETs in there. Something like this. Take a look at a couple of these. Okay, take a look at a couple of these. I would avoid something like this because it doesn't have a lot of descriptions on there. Doesn't have a lot of names and descriptions. Something like this. This one looks pretty nice too. We'll take a look at that real quick. Okay, so just one of these tables. Let's look at one of these tables. You want to search for and download one of these tables. I'm just going to do this real quick, so if it's not coming up, I'll go to the next one. That's being difficult. A lot of these sites, you know, they have all kind of things on here. So here's a quick table. It's showing you different kinds of grounding techniques. It's showing you a couple different transistors. That's not really that detailed. We need something a little bit more all-encompassing. Let's say this looks pretty good. So this is even showing you some connections. Okay, so that's a wire. That's a connection. That's not a connection, right? When two wires cross and there's no dot in the middle of it, that's not a connection, okay? Input bus, output bus, that's just a flag that you put on inputs and outputs. Terminals, bus line, AC signal, that's usually, you know, with the alternating current. DC, it'll be plus and minus. A Schottky diode, probably not going to get into much of that. A laser diode, probably not going to get too much of that. A Darlington transistor, buffers. Those are a little bit more specific in the situation. A single cell battery, this is what you want to know. Your battery symbology, your push button. This is a push button switch. This is SPST switch. So knowing how to read these. What is this? These are all switches. This is a switch and this is a switch. Switches are the way you articulate this abbreviation is single pull, single throw. Okay, that's a single pull, single throw. That means it has one pole on this side, and this is the throw. The throw is the arm, right? A switch is a mechanical device, right? That basically just breaks a connection. It has a single pole, which is over here. That means it has its output. It only has one output, basically, and a single throw, which is the throw is basically the switch here. Now, if you have an SPDT, that means you have a single pole, but you have a double throw. So you have, or you have a single pole, double throw. So you have two poles basically on the other other end of it, on the output end of it. So the switch can be, you can configure it to be, you could still configure it to be just on off, or you can configure it to be like high low or something like that. Now here you have a dual pole single throw. A dual pole single throw means that you have two switches in this line here. If you see that dashed line in between, that means these two switches are in conjunction. So this is a situation, let's say you had, which typically isn't done, but let's say, I don't know, you had like an AC signal and you wanted both lines to be disconnected at the same time. If you have anything, it doesn't have to be an AC signal, it doesn't matter. If you have a line that you want two lines to be disconnected simultaneously and you want them to be turned on simultaneously, you would use a dual pole single throw switch. That means you can throw two pulls in a single throw, in just the throw of that one switch. Now here's a dual pole dual throw switch. So that means what? You can have two items on this switch, and you can throw it to two different poles. So you can throw it in two different directions. Again, it's just like this one, except you have two lines now that you can throw. Okay, so that's your basic switch diagrams. There's lots of switches. Switches can be very unique, so we're not going to put an exhaustive list on there. And you don't have to learn an exhaustive list of them. Just having that idea and knowing how to read that, so when you're shopping for switches, you know what it is. Okay, that's your transistor symbology, your flip-flop. Again, I'm just going through the ones that are going to be most common that you're going to see most often, okay? That's going to be, it says a solenoid generator is going to be like a sine wave generator, or this is going to be a pulse generator, some kind of frequency. All of these relate to frequency generators, okay? There's grounding again. Photodiode, Zener diode, this is all going to be digital. And this is what you're looking for. This is why, if you're saying, oh, why are you skipping through this kind of quick? Well, it's because I'm just looking at these in packages. Like, these are all grounds, okay? These are what I call like special case diodes and transistors with respect to at least these three right here. Those are special items here. This is just a MOSFET. These three are digital devices. Okay, these are the kind of things you want to get familiar with. A variable capacitor, so just like a resistor. If you see a variable resistor, you see a variable resistor is going to have a line through it, like a potentiometer can even be annotated in that way. Or like you see this rheostat, it has a line through it. That means it's variable. Okay, the variable, anything that varies, usually it's going to have a line through it. So a variable capacitor, which aren't used very much. You typically have a variable capacitor, and like a tuner for an FM AM radio is a variable capacitor. Okay, this is a tapped resistor. You can almost look at that like a potentiometer. Some more digital gates. These are transformers. I talked a lot about this in the Tesla coil video. So those are depictions of transformers. Antennas, basic amplifier. That is a basic amplifier block model. This is a operational amplifier. We saw that a lot in the practical electronics video. So these are going to be a lot of the ones you're going to pay attention to. This is a resistor. That is going to be, it looks like a preset resistance that has to do with a potentiometer. But anyway, you're going to see a fixed resistor. They're calling this a rheostat, which it very well could be. You're going to see the kind of same kind of symbology for a potentiometer, which is just a variable resistor. Right, so like a volume control is a potentiometer. This is a non-polarized capacitor, and it's showing you both ways that it can be denoted. Okay. This is a polarized capacitor, and it's showing you the two most common ways. So this U shape is the negative side, and they put the positive side here for you, but you know that the U shape is going to be the negative side, and the positive is right here. In this case, the side that is not shaded is going to be the positive side if they use a different symbology. This is an electrolytic capacitor. That's a relay. Step-up transformer, step-down transformer, talked about that in that video. A buzzer, loudspeaker, motor, fuse. And that's basically it. So again, going through, getting something like this is a pretty good one. Going through something like this and getting familiar with your symbology is good. This looks like another one, a good one, because it has a good description here. So that's a cell, which is basically a battery. That's another battery description here. Your AC power, we saw that. The single pole, single throw switch, the resistor, capacitor, inductor. I don't think the inductor was on that other list. That's an inductor. Diode, your transistor, and an earth ground. So something like this, if you want to start with something like this, just to get some of the symbology, this is like really a lot of the basic symbology under your belt. And then you can go to something like this for some more specific things. So that's one, is getting something like that under your belt pretty good. Or just printing it out for having a reference. Then understanding the components. Okay, so having a good understanding of some of those components, and that is something you can also use one of those lists for. So you can go on a list like that and you say, okay, and ask yourself these questions. What does a resistor do? Or you can cover this up so you can see, right? Okay, a switch. What does a switch do? Okay, the diode. What does a diode do? How would I use it in a circuit? What's an NPN transistor do? How do I use that in a circuit? What's the ground? How would I use that? What's an AC source? Why would I use that? Okay, And you get more advanced and you go through something like this and you say, okay, a Schottky diode, why would I use that against a regular diode? A Darlington transistor, why would I use that? A P-channel Jeft, why would I use that? Okay, a buffer, why would I use that? Okay, anything, a photo Darlington, why would I use that? Very special situations, I wouldn't expect you to have an answer for everything because some of these are very specific and you might not need to understand. It might not come up to in anything that you're interested in or any kind of device that you might be looking into. But this is very good training for you, is to go through these things, lists like this, and have an idea and see if you can explain to yourself what that thing does and why you would use it in a specific area in a circuit. Okay? Then familiarize yourself with common components. Okay? I have some common components listed here. Do you know any of these? Of course, there's many other components. I just wanted to keep everything one line and keep this kind of short. But you should be able to know, let's say, for example, if I asked you, which one of these is an IC? Okay? Which one of these is a timer? Okay, which one of these is just a regular general purpose transistor? Okay, you should know that. Get basic tools and equipment. Okay, that would mean a soldering iron, a breadboard, and a multimeter. That's basically all you would need, and of course some tools like some snips and some needle nose pliers. Of course, you have your screwdrivers and stuff like that, but that's all you really need. You don't really need that much typically for doing basic electronics. Okay, your breadboard and all this stuff is pretty inexpensive. I mean, for a soldering iron, a breadboard, and a multimeter, I mean, that could cost you maybe $50 for all of that. You could probably get away if, of course, you're going to be the cheaper end. A breadboard doesn't cost very much. You can get a multimeter today for, really $10 or even less. Really, you could get each of these items for about $10 a piece. So, but it's your discretion on what quality you want. This is the thing. I don't know how many of you are really, into this. Like for instance, I have an electronics shop in my house. I've had one always, basically, most of my life. I've had, done electronics in my house, or in my bedroom even, or something like that, So I don't know if that's what you're looking for, or you're just wanting to set up something on the kitchen table once in a while. However, your mode of seriousness is, and that'll dictate what kind of quality of materials you want to buy. Again, like I'll show you, maybe we'll walk through and I'll show you what would be a more basic setup, and then what would be like the kind of setup that I have, but you don't have to go into the whole kind of what I call a laboratory setup, like a lab setup, like the ones that I have, or ones that you see other like electronics YouTubers have, where they have a dedicated room and they have their oscilloscope, they have a benchtop multimeter. I'm talking about a multimeter here. I'm talking about just a handheld portable multimeter, not a benchtop multimeter. They have a benchtop power supply. I have a benchtop low voltage one and a high voltage one that I built. I have a variac and all that kind of thing, a frequency generator. That's a typical laboratory setup, but you don't really have to go that far into it. Tailor your education and figure out what you want to learn and why. So that's the biggest thing. That's probably the biggest thing one of the biggest things on this list, and that's something I really wanted to talk about because a lot of people here have been asking me about how to learn and this and that, and part of it is to answer your own questions, not to have me or anyone else answer every question. That goes back to the reverse engineering bit. The way to learn this is to reverse engineer the process. So what you do is you find things that you're interested in, you find schematics of it, and then you figure out and you try to learn how it works through looking at the schematics, through dissecting the schematics, through picking up bits and pieces of information so you can figure out how the thing works. So that's how you're going to do this, okay? But the way to do that most effectively is to tailor your education. Now, what does that mean? That means that you pick out and you figure out what kind of electronics do you actually want to learn. I think someone on here a couple of weeks ago said that they wanted to learn DA converters, and I sent them a book on DA converters. If you want to learn DA converters, and you don't spend 20 hours a week learning about, buck power supplies and flybacks, okay? Depends what you're interested in. If you're interested in amplifiers and stuff like I was, then you would put a lot of time into studying amplifiers. Then you have to think of what kind of amplifiers. Are you wanting to study like a lot of integrated circuit like op amp stuff? You want to do transistor stuff? Are you trying to do vacuum tube amplifier stuff? Do you want to do a bunch of digital stuff? Do you want to, that would go back into like the DAC stuff. If you want to do DAC stuff or anything digital, you need to focus on digital electronics and get a hold on that. If you're doing digital electronics, I'll tell you right now, you'll want to put a lot of time, effort, and research into PCB design and finding a PCB design software. That's the other thing too. See, depending on what kind of area you're going to go into or want to go into will dictate also how those items might be built. Okay, so like for me, because I'm into amplifiers, most of it is point to point. Most of the stuff that I do in electronics is preferably done by hand. Okay. But if you're doing something digital, you're not going to be able to, in this day and age, to do most anything digital by hand because the packages have gotten so small. Most things are surface mount devices now. So you're not even going to really have that much of a shot. When I say, hey, get a soldering iron, a breadboard, and a multimeter, yes, that is true, but there's a caveat to that. Depending on what kind of electronics you're doing, like if you're going to go way into digital and stuff like that, then you're going to deal with a bunch of surface mount devices which are difficult to solder by hand. It's not impossible, but your lab setup is going to have to be a little bit more sophisticated, and it might be more than you're wanting to invest, or it's a steeper curve, learning and application wise and equipment wise, if you're going to start out wanting to do your digital stuff by hand. But it is possible. It's not that much. It's not necessarily completely, more difficult. It's just again, it's going to be more tedious, and you're gonna have to put everything under a microscope basically. So you're gonna have to have a microscope, and you're gonna have a different kind of soldering iron, and it's just gonna take a little bit more steadiness of hands and that kind of thing. Okay, it's a little bit more tedious kind of work. But it doesn't mean that you couldn't do it. It's just, again, it's a different kind of style of application. So you have to take that into consideration. That's why this is important. You have to think about, if you want to get somewhere, you got to know where you're going. So this is one of the biggest parts, is figuring out what you're trying to learn and why, and then setting up this education for yourself. Again, I talked about in the previous video, what you're doing here is engineering in and of itself, not just building the circuit. The engineering is not just building the thing. It's also building the situation around the thing, okay? Just like manufacturing. It's not, designing a certain product is not just the part of engineering. Engineering is also designing the manufacturing process around the product, right? So this is going to be engineering the educational process around your product. And the way to do this is to take note of all these things, especially this last one, which is getting to figure out what you're trying to do. So enough about that. Let's get back into this book. As I said earlier, these books are very common, but we'll just go through this, and I'll kind of talk you through and look at some of the most common circuits that you're going to go through here. So it looks like he does have a basic intro with components, and he describes some of the most common components. I would definitely read through this if you're still not that knowledgeable about some of these components. Figure out the basic components, and then you can just go through. We're just gonna flip through the book, but you you can see in the table of contents the kind of things that they're going to cover. And like I said, these books are very common. So there's going to be a lot of things that are just kind of staples in the electronics community that are like, beginner circuit kind of stuff. He does have a lot of more advanced things, which I think is cool. A lot of stuff that's very unique, but we're just going to start scrolling through this. And I'm going to showing you the process of how I learned. The only thing I don't like about this, the only thing I see if I were to do something like this, the only difference I would make is that I would put them in order of kind of complexity and difficulty, because these are it's just all spread around. So there's no particular order in this. But anyway, let's just go look at some of these circuits. Okay, and he has information on resistors, information on capacitors. Symbology for transistors, integrated circuits. Okay, let's see. Oh, he looks like he has some information on PCB, which is nice. Okay, sound operated switch for lamps. Someone just asked me about this the other day, about like a clap switch. Okay, so first thing you have to ask yourself is, can you read this? And why or why not? What confuses you about it? What don't you understand about it? What do you understand and what don't you understand? Okay? That's the kind of thing that you want to figure out. We know that this is a clap switch, right? And that's a microphone, so we can usually start to read schematics left to right, just like you would anything else. Okay? And then we're trying to decipher what the operation is of pretty much all the components. But to do that, and he's going to have a little description here that might help you. But to do that, typically the best way to do it is to break things up into blocks. So what I would do is take each one of these transistors either in one block or two blocks, because a lot of times the transistors can work in conjunction with each other. Like for instance, these first two transistors are working with each other as a gain stage. I can already tell that. Now this one looks like it's actually a current source for this next transistor. Okay? And these two transistors are going to be powering, this is where these two transistors are going to be powering the lamp, this light bulb here. Okay? And that's just a very brief description of what's going on. But again, I can tell that by looking at this, cutting up the sections of this circuit. This might look complicated to you, but again, if you break it down, it's not that complicated. So you can say amplifier stage here, current source here, and then these are basically current sources as well that are going to be powering this lamp. Okay, so we have a basic understanding of how this circuit is laid out. This is a pretty complex. The other thing I would do is when you look up a schematic, don't look up that one schematic. Just because, okay, this is a clap circuit, there's tons of clap circuits, because there's thousands of ways to accomplish the same thing. So you wouldn't want to just go, and this is how you learn about this. So I wouldn't just go, so sound operated switch for lamps. Okay. What I would do is go, if this were me and I wanted to learn this, I would put clap switch schematic in Google, and then go on images, okay, and just look at different ones. Okay, this one's using a 555 timer. Interesting. Look at this. This is way simpler. It still has its microphone. So this is what it can show you. What are the most essential components? This is what you want to do when you're reverse engineering something, is you want to find out what are the most essential components in this circuit, that will facilitate this function. Okay, I've got my condenser microphone. I know that. I have another transistor here. That's a gain stage. Okay, then I have the 555 timer here. What's the 555 timer doing here? I don't know. Let's figure it out. Let's figure out. Well, I know it's going to be operating as a certain switch. So basically, where is this pin going? The pin on the output of the transistor is going to the trigger of the 555 timer. Okay, so I guess the frequency that the microphone picks up will then go into this amplifier. That'll amplify, then it'll go into the trigger of the 555 timer, and that will raise the voltage enough on the output of the 555 timer that it'll then turn on the LED. Something like that. That kind of makes sense. That's probably how it works, huh? Okay, I go into another one. Okay, why'd they use 2 transistors here? Another thing to keep in mind is, why do they keep using a BC547? All right, I want to think about why they're using that one. I don't know. Is it a high impedance input transistor or something, and that's kind of useful in this situation for some reason? That's something I'd want to figure out. Why is this schematic seem to have more components than this schematic? You know, why are they, what's going on with this? They got a nanofarad capacitor here. Why is that there? Okay, these are questions I'm going to ask. You just ask yourself more and more questions about things. Okay, this one has it hooked up to a relay, which is, in a lot of ways, I think it's more sensical, because you can just build a switch and put whatever you want on the other side of it. You know, like this one that we saw initially. See, it's slaved basically to this lamp, this light bulb, because it's in the circuit. But typically, you know, I think the wise way to do this is to put it actually with a relay. Okay, now we see another one here, clap switch with a transistor. Okay, so this has a microphone, and it goes into a gain stage, and then it comes out. And then the LED is turned on by that transistor there. Okay, simple. Right, so that's the thing. Are you just wanting to turn on an LED, or you wanting to turn on a light? You see that the technology that has to be used or implemented is different for each one. Here's one over here, and look, they're using a flip-flop circuit. All right, could you tell that was a flip-flop circuit? So that makes sense, kind of. Does that make sense? So we have a microphone, we've got gain stages here, then we have a flip-flop circuit. Does that make sense? Well, yeah, I guess it does make sense, because what does a flip-flop circuit do? Well, it flip-flops. That means that at one phase, this transistor's on, and then you do something to turn the other one on, right? In this case, you would clap to turn it on, and you would probably clap to turn it off. So this one of these flip-flop circuits is there to turn it on, and then one of them is to turn it off. That's most likely how it's operating. Here's another one with a flip-flop, okay? Again, these are the things. And then I would take some of these schematics, and then I would think about this. Oh, and look at this. He's got this annotated. This is something that a lot of people don't do, and this is what the rigor in learning electronics is most schematics aren't going to be annotated for you. He's got one, look at this, using a 741. But there's something I want to show you here. Okay, look at this. So he's got it annotated. So audio signal amplifier stage, he's got that annotated. Bistable multivibrator, which is the more sophisticated term for the flip-flop circuit. And then you have your output switch. Okay. But see, he's got the stages outlined here. And that's how you want to be thinking about schematics. You just don't think about the whole thing in its entirety. You look at it. That's why a lot of people look at something like this and they say, oh man, look at that, it's complicated. Not really. It's got a stage here. It's just 3 stages, and they all have a different purpose, and you put them all together, and then that makes a complete function. Okay, that's all. Okay, so I want to get through more of this book before I go and just get on the clap switch. But that's cool. That's a cool project to do. The one thing I wanted to mention again is just take a couple of these schematics. I usually want to start with at least 3 schematics, and then compare them to each other, and then try to figure out if you can find a benefit. What's the benefit of doing it with like a 5/5 timer as opposed to doing it with a clap or with a flip-flop circuit and what have you? do some research on that and see what you can find out. Okay, let's continue. Battery low indicator. So they're using an IC circuit, and you have an LED that has two different. They build like a multicolor LED, so it's able to give off red and green. Okay, and then it has an adjuster here. So you adjust this. You basically adjust this this IC to where it'll turn on this LED when the battery voltage gets low enough, and it'll turn this LED on. That's a simple circuit, but it'll the simpler really the better, especially in the beginning, because that'll give you more of an understanding. Battery voltage monitor. That seems kind of too complicated for us to. Very specific and complicated. That's again, I wouldn't go into something that's so specific and complicated like this. Infrared sensor, create object detection. Not terribly complicated, but very specific. But that would be something that'd be interesting, especially if someone is interested in doing something like with Arduinos or microcontrollers. Okay, so that would be a circuit to pay attention to. Especially if you want to do something in like robotics or something like that. Control circuit. Not terribly interesting, but there's a lot of reason why I'm not going. There's a lot of relationship between these first couple circuits here. Microinverter. Okay, so now we're taking. That's kind of. I mean, that's pretty cool. So this is how you would take. You take your 12-volt battery, and then you get 230 volts out of it if you have, or whatever you're going to get out of it when you have a transformer. So, so take your DC voltage and put it out into AC volts. I wonder how many amps this thing is. So it says. It's a 2 amp secondary, so maybe somewhere around 2 amps that this thing might be operating at. That's, I think, a useful thing to understand. First, I would learn basic power supplies. This is basically a power supply in reverse, but I would first understand basic power supplies, and then you could get into inverters. On-off mosquito repellent. That's interesting. A cable tester. I saw this the other day. I thought that was interesting as well. So sometimes you can build, think about something that you might need. I always thought a very cool project would be even, let's say if you're starting your electronics lab, one thing is to build, look into a frequency generator and build your own frequency generator instead of buying one. That's a good one. 3-phase induction motor starter. It's kind of an industrial thing, not really that interesting on the smaller electronics level. Multiple purpose listening device, so we know that this is some kind of, this is just an amplifier circuit. Power on reminder with LED lamp. There's an FM radio. I think that kind of stuff is pretty cool. if you've never, I think that's also a stepping stone. I know today is kind of, we're in a different time, but one of my favorite things to do when I was a kid was build radios, especially tube radios. That was very satisfying. But even do it with some transistors. This one, he has it annotated as well, which gives you a good idea of what's going on. So oscillator, that's what's going to pick up the signal, and then we have a preamp, then we have a driver, then we have the power amp. DC to DC converter, this is like some kind of buck or boost converter. Typically you're trying to step up a voltage with the DC to DC converter. I'm not sure exactly what the purpose of this one is. Remote control using wireless doorbell. That sounds interesting. RF signal detector. That's cool. Well, it's basically a radio, but you're using an IC here, which kind of cleans things up a lot. Audio mixer. And a lot of this stuff, you don't necessarily have to, obviously, you don't have to build every one of these. You might not have a purpose or interest in it. But to go through here and seeing how things are constructed, like maybe you see this and you say, oh, well, that's how an audio mixer is wired, okay? That gives you a better understanding of how things work. Clock tick-tock sound generator. Boy, does the word tick-tock have a different meaning today, doesn't it? That's a cool thing to learn about. Battery charger with automatic switching. I think these things are interesting. Battery circuits can be they're more complicated than you would think. Ooh, earth leakage tester. That's a good one. That's pretty cool. That's definitely one that you could... I wonder what the LEDs would represent. I wonder if I would get in... I wonder, I guess it's just the order of magnitude of the voltage, but I wonder I'd make it if it was more specific. But that's a very cool kind of device to have. You're going to see a lot of alarms. Alarms are very popular in these kind of books. Temperature tolerance checking system. Headphone amplifier. Those can be pretty interesting because of the low impedance. Or it's really, I guess, in a way, a high impedance. They're higher than speakers typically. So high impedance, how to drive a high impedance load is kind of what you get into the science of with headphone amplifiers. of some sort. LED lighting for Christmas. So this is like a lighting circuit hooked up to a flip-flop. That might be an interesting one, a pretty simple one. You could see kind of all the different things you could do with a flip-flop. Look, we have our general transistor there that we talked about on the list, 2N3904. Bedroom light. Let me just scroll here a little quick before we end this. I think you guys get the idea. Tons of stuff, a lot of alarms. There's a fire alarm, dancing lights. This will give you an idea. This gives you a good basis for figuring out what you'd like. A wire break. This is something, I don't know, you could use. You could use around the house even, or something. You could find a purpose. Some of these things you can actually find a purpose that might be useful for yourself. At any rate, I think that pretty much sums it up. Again, this is part of the process. Again, I'm going to put this in the description of the video. There's 300 here, so there's plenty of material to go through. And like I said in the beginning, define what you want to learn and what your purposes are, and go from there. I didn't mention one thing. I didn't talk about microcontrollers. If you're wanting to go into microcontrollers, then that's something that you'll have to. Some of this stuff will be useful because a microcontroller doesn't do everything. You use a lot of external circuits for microcontrollers, but that'll further dictate what might interest you. So I would even make a list if you want. Make a list of the kinds of projects that you want to build, and then figure out where the schematics lie, and find some schematics for them, and start reverse engineering them, and then build a couple of your first circuits. If you guys really have, I do have a circuit in mind that I want to show you guys relatively soon, just for the heck of it, to show you, a simple kind of useful circuit that you could have around that could help you from the day to day. Otherwise, if there's really a circuit that someone wants me to review on here or build, then I'll do it. So just keep in touch, and I'll see you guys next time. Have a good one.